Hi, and welcome to this tutorial. In this tutorial, I'm going to model with Rhino and with Grasshopper. I'm going to model Peter Eisenman's Berlin Holocaust Memorial Museum. As you can see, this is a building that is a public space. It's comprised of a lot of a grid of concrete blocks, each one of them having different heights. And all together, as a whole, they form this kind of like undulating surface on top of them. And I think this is a really nice example, like a really good introductory example to do with parametric modeling. And for this example, I'm going to be using Rhino and Grasshopper. I use this exercise a lot in my courses, so I thought that doing it here today as a tutorial would be interesting for many of you to learn something. I'm going to do this in two parts. The first part is going to be, I'm going to start with like a super basic example where I'm just going to do a basic grid. I'm going to populate that grid with boxes, and then I'm going to adjust their heights to a design surface that we're going to create on top of it. And then I will probably do a second part where I will try to replicate some of the more nuanced details of the actual example. So for example, instead of being a pure grid, I will probably adapt the grid to a parcel that is not a square. I will probably tilt the boxes because that's how they are in real world. And we will try to replicate this effect where the closer we get to the boundaries of the site, some of the blocks start disappearing, fading out. So that will be part 2 of this video. I don't know when are you watching this or how you will be watching this, but feel free. A lot of the info related to this video and the live stream that it belongs to will be on the description right here. So feel free to check it out. Before we start modeling anything, I'm going to describe with a quick sketch what I'm going to do for the first part, for the basic part. And I have this like sketching board here that took me a lot to set up, but I'm very proud of it. So what we're going to do is we're going to assume that we're going to start from a flat surface, all right, like this. And basically all the blocks that we're going to design are going to be something like this. So they're going to be displayed in an array, in a 2x2 grid, and somehow they're going to form this kind of like surface form on top of them. So in order for us to replicate this form, how do I create a new sketch? Okay, whatever. In order to create this form, what I'm going to do is, first of all, I'm going to start by creating a grid of points. Okay, this grid of points is going to serve as the base for all those blocks that I'm going to replicate. Then probably the second step that I'm going to follow is that I'm going to create some blocks on top of them. So I will be creating these blocks here, and another block here, etc. I'm really bad at sketching this, right? It's very difficult to do it on a vertical screen. And then the third part that I will follow will be, once I have all the blocks, I will create, for example, I will probably create that in Rhino. I will probably create some kind of like surface on top of this, and I will then take each one of those points and measure the distance to the design surface, measure that distance. And use that distance to drive the height of each one of the boxes that are going to form this monument. Okay? Why am I choosing a surface as opposed to doing, for example, some kind of mathematical rule where, for example, I could use a function. I could use the sine function that you guys know does something like this. I could use a sine function. I could use a Perlin noise function to calculate the height instead of having the surface. But since it is an architectural project, it's probably my understanding that if you guys were architects and you wanted to really, really have control of the shape of this monument, you would want to have something that you can have a bit more fine, almost like touch, And I think that modeling that surface on Rhino and like touching it and modifying it with control points would feel a bit closer to the real experience if you were making this model on site and you will not be thinking about mathematical functions or probably noise. You will be thinking about like, oh, I want this area a bit higher. I want this area to be a bit more depressed, right? So that tactility, I think it's nice, and we can get something close to that by modeling a surface in Rhino and then using that as the control surface that is going to drive the shape of these boxes, okay? So that's why I chose to make that. You could choose a mathematical function, that's perfectly fine. This is my choice as a designer, okay? So let's start. The first thing I'm going to do is I'm going to create a grid of points, and for that I'm going to go to the vector tab, and I'm going to go to the grid category and use a rectangular grid of points. Just so you know, I happen to be an icons person when using Grasshopper. It's my experience as an educator that icons are much easier for beginners to remember, because if you're using Grasshopper, it means that you're probably some kind of visual thinker, and remembering images is much easier than remembering text. I find that so. So I will be using Grasshopper with icons. You can change those two modes between icons and text here on Draw Icons. But anyway, if you sometimes get lost, I will be pointing to where these icons are on the menu. I will somehow, I don't know how yet, but I will post all these files to some kind of repository that you can download. So you will be able to see them later on, okay? Okay, so we can create a grid of points, and then what you can see here is that this component takes a plane, which right now by default is the XY plane, and it takes the sizes of the cell and how many elements in each direction, X and Y direction, we want to have. And the result is the outlines of the cell, so the rectangles, and the planes. So, sorry, the points, which is what I want here. So I'm going to hide this component, and I'm going to connect here a points parameter box so that I can just clearly see the points here. And now I'm going to connect some sliders here to this component so that we can control the size of the grid, okay? So for example, the spacing between points in the X direction, I'm going to say that's going to be a slider with decimal precision 10, and now the size in Y is going to be another slider, and then how many elements, and you see that I used decimal values here. That's because we may want to have like really fine control between them. But for example, when it's about the number of elements on the grid in each direction, we may want that to be an integer with no decimal part, just because we don't want to have like 95.7 elements, right? So for that, I'm going to use a slider with an integer value here. And now I have a grid of 100 by 100 points, which are separated by 10 by 10, okay? That's a lot of elements. I'm going to crank this down a little bit because it's going to get really busy very soon. So now that we have a grid of points, we can. I'm going to crank this down. This is very, very busy. We can probably like crank it up later on. So now that we have a grid of points, I want to create boxes on top of these points. Before I do that, let me create those boxes. I'm going to go to surfaces and I'm going to go to primitives. And here I see that I have 5 options for boxes, okay? I will want to use, for example, I could use a lot of different things, but I think I want to use create box center on a plane. Just because this can work out of the box if I plug in points, right? Nevertheless, something that I would like to do is I would like to notice that this component is asking me for planes, and planes are a much more interesting structure than points, because points only define location in space, whereas planes define location and orientation. All right, which is a much nicer structure to work with. So because it contains more information. So I would like to not let Grasshopper decide for me how these points are turned into planes. I would like to be the one who decides which planes are those that are here. And right now it may not seem very important because we're going to do, all those planes are going to be parallel to the XY, but you will see on the second part of this video, as soon as we start tilting these boxes, having those planes will be of extremely important because we will be tilting those points, those planes, to create those tilt boxes, okay? So I'm just going to, here, I'm going to go to vectors and I'm going to planes and I'm going to create an XY plane based on those points, and that's what I'm going to use to feed to the boxes. I think my planes are really large on my screen size, so I'm going to go here to the options, preview plane size, and lower that down to 0.5, for example. Maybe that's a little, nah, that's fine. That's kind of good. All right. So now that we have boxes that are centered on these planes, now I would want to control the size of these boxes, right? For now, we're just going to control, well, we're going to add values. For example, here, we're going to add values of 0.00 for the X value and 5 for the Y value. And we may want to control these guys something like this, all right? And you can see that this controls the dimensions of these boxes. And if we combine that with this, then we start getting an array of boxes that is a bit closer to the monument. Now, I'm also temporarily, I'm going to plug in another number for the Z height, even though we want the Z height to be controlled parametrically and to be different for each one of them. But just for the sake of trying, I'm going to test this with a value. And what I see is something that I don't really like very much right now, which is the fact that the Z height is making these boxes grow in both directions. And so up and down. And if I'm thinking of these planes here as the base on top of which the box grows from, then it's not nice. It's not pure. So I think I want to control this better by, instead of using a box that is centered on a plane, instead of using that component, I would want to use a component that has a box that is controlled in size by domains. All right. What is a domain? A domain in Grasshopper is an interval between two numbers. So it's something that starts at a minimum value and something that ends at a maximum value. You can see that if I plug these guys here right now and I turn this one off, you can see that the default values are -2 minus 2 plus 2. These are -5 and 5, and C is from 0 to 0.25. And you can see that these boxes are indeed now starting from this plane as the base, which is an effect that I want much better than the previous one that I had. So what I can do is, I don't know if I can plug in this directly in here. Yes, so I can plug it in and it will convert the value of 1.75 directly to a domain that goes from 0 to 1.75. So what am I going to do? What I'm going to do is I'm going to take these values here and I'm going to convert them to domains that I can plug in here. So I'm going to do that by going here to the domain tab and constructing a domain. The domain is going to ask me for two parameters, the start of the domain and the end of the domain. The end of the domain, for example, for X is going to be 3.58, but for the start is going to be the same value in negative form. So I'm just going to use that negative form and I'm going to plug this into X, and you can see that now this value is controlling, because if I hadn't done the domain, if I hadn't created a domain and I had just plugged in Y, you can see how the box is just growing in one direction only. Maybe that we could have gotten away with that. I don't think it's a very clean solution. So I think this is better. So I'm going to copy paste this. I'm going to create, I'm going to plug this in here, negative, negative, and you can see that very soon we're getting a spaghetti here. That's why it's very important to keep your Grasshopper definitions tidy and clean. I'm not sure if I will have time to do that now, but definitely when we post this somewhere, we will make the effort to clean them up and comment them a little bit better. Okay. Same for the inputs. Value and value is not a great thing to read. This should read like X size of the box, Y size of the box, etc., etc. Okay. Okay, so we're good. So we have a parametric definition with which we can create an array of concrete blocks that are separated a control parameter between each other. All right, so we're getting there. The next thing we're going to do is, because we don't want a C height that is fixed for all the boxes, but we want those boxes to adapt to an undulating surface. What we're going to do is we're going to create a surface in Rhino that we will import into Grasshopper, and then we will perform some calculations to figure out the distance between the plane and that surface, and then use that distance as the height of these boxes. Okay. In order to do that, I'm going to go here to Rhino, and I'm going to physically draw a surface here in Rhino. How am I going to do that? I'm probably just going to make two curves, something like this. And now I'm going to make another one, something like this. All right. I'm going to maybe move one of them all the way here to the end, and then I'm going to loft them, I guess. I don't know. You guys probably you guys feel free to experiment. How do you think this could be done? And now I have this surface that I can perhaps like center a bit better on top of here, and I may want to remove these two curves that I created. And I have now this surface, all right, that is floating on top of these boxes. I'm going to import that surface by creating an empty box to contain the surface. I'm going to right click here, set one surface. I'm going to import this here, and now in Rhino, so that I have a clearer view, I'm going to hide this object. And now you can see that I have this parametric, well, the surface is not really parametric, but that I have this surface on top of my boxes. The next thing that I will need to do is that I want to figure out what is the vertical distance between each one of these planes and the surface that is living on top of it. So what I will do for that is I'm going to perform a projection operation. I'm going to take all these planes, and because I know where they are, I'm going to take that point, the point that is at the center of the plane, I'm going to project it vertically into the surface, and I'm going to figure out where it hits that surface. And after I do that, I'm going to have another point on top of that surface. I'm going to compute the distance between both of them, and then that's going to be the value that I'm going to feed into the C height of these boxes. Okay. So in order to do that, I'm going to use a project point. This component is a component that takes any point and any vector and projects it onto some geometry that we can specify. If you guys don't know where this component is, I can Control Alt and click here, and you can see that this component belongs to the vector tab inside the point category. It's project point here. All right. This component is asking me for a bunch of things. It's asking me for the point that I want to project. It's asking me for the direction of projection, and it's asking me for which geometry I want to project onto. Well, that one is the easy one. That's going to be the surface we just brought in. And for the points and for the directions, I want to keep it clean. So what I'm going to do is, because I want these planes to be exactly what I want to work with, I'm going to deconstruct these planes. This was here in vector plane. I'm going to deconstruct this plane into its components. So the origin, that is the point that I want to project. I could have taken it from here, but this is a little cleaner to do. And I'm going to use the normal direction of the plane, so the C height. I'm going to use that as the projection direction. And you can see that the result is that I'm getting this family of points that is projected on top of the surface right here. All right, so very easy now. So I can just go here, where is it, point, distance, or I can double click and type distance to compute the distance between 2 points, the origin of the plane and all the points that I just created. And if I use that, I'm going to move this all the way here. If I use that distance as the C height of my boxes, you can see that all these boxes are now adapted to the geometry of the surface. All right, isn't that nice? Let me disable the visualization of some of these things. Yeah, now, and let me do like a preview, custom preview. I think I'm going to render them pink. Yeah, but whatever, you know. Now, isn't this nice? Huh? The nice thing about this way of modeling the monument is that if I now unhide the surface, okay, and if I now touch the surface, activate control points with, for example, F10, and then I drag any of these control points, that was not nice, but if I drag it up, for example, you can see that everything adapts correspondingly, and I can hide the surface again, and I get this like massive bump as part of my modeling. So this is very nice because I have some kind of like very tangible way of touching the surface and adapting the overall design of the monument to this guiding surface, okay? So with that, I think I'm going to finish this first part of the tutorial. For the second part, I will be adding more detail according to the real the monument, and you will see somehow either on the screen here popping up as a card or on the video description, you will see a link to the second part of this tutorial. Okay, thank you very much.